So we're going to name a few more alkane compounds here. Got one example which will help us out with an additional rule to consider. Okay, for this compound, the longest continuous chain is actually 1, 2, 3, 4, 5, 6, 7 carbons long, as shown here. But what we want to decipher is which direction to number, left to right or right to left. Well, we want to go in the direction that gives us the lowest possible combination of carbon numbers for the substituents. If I number from left to right, I end up getting carbon numbers of 3 and 4 for my substituents. Now that versus going from right to left, I get 1, 2, 3, 4, and 5 for my two substituents. 3, 4 is a lower combination than that of 4, 5. So I'm going to use the 3, 4 combination in naming my substituents. Now the two substituents I have are a methyl group at position 3 and a ethyl group at position 4. Which one am I going to name first? Well, since both of these substituents are alkyl chains, they are the same priority. Substituents with the same priority end up getting listed alphabetically. So for alphabetical order, E comes before M, so I'm going to list out the ethyl before the methyl. So 4 ethyl first alphabetically, then followed by my methyl group next alphabetically. Those are the only two substituents. So now I just name out my parent chain. My parent chain is 7 carbons long. 7 carbons is heptane. So the name of this compound is 4-ethyl 3-methyl heptane. Okay, here's our next example. Structure actually. Just going to look at another rule to consider in naming alkanes. So as with any of these, I want to look for the longest continuous carbon chain. Now this one actually does not run left to right or right to left, straight horizontally, like my previous examples. That would just give me 5 carbon length. The longest carbon length is actually 6 carbons. Now that 6 carbons can be numbered one way. 1, 2, 3, 4, 5, 6. You could also start from number 1 being this carbon here, and ending with carbon number 6 being here. It does not matter which way I go, because I end up with the same number of substituents, and that would be 3 of them in both ways of numbering. They're both equal. If I have more than one path that gives the same parent length, I look for the one that has more substituents. Well, since both paths lead to 3 substituents being made, there's no preference there. The next rule I got to consider is that when I'm numbering the longest path, I want to use the path that actually gives me the lowest possible number for these substituents. If I number from kind of like diagonally right, going down, it gives me substituents at 2, 3, and 4, versus if I went in the opposite direction, I would have substituents at 3, 4, and 5. So 2, 3, 4 gives me a lower combination of carbon numbers than 3, 4, 5. So my substituents are going to be numbered 2, 3, 4. My substituents, I've got 1 two methyl groups and then an ethyl group out here. So at positions 2 and 3, I've got methyl groups. And since I have 2, I don't say 2,3-methyl, I say 2,3-dimethyl. I use that Greek prefix to let me know that I'm using 2 methyl substituents. And the 2,3 lets me know the carbon numbers that they're located at. My ethyl chain is located on carbon 4. Now, which one do I list first when I'm naming this compound? Alkyl groups are the same priority, so we just list out whichever one is alphabetically first. The one that is actually alphabetically first is the ethyl group. The prefix di does not get considered. So it does not get alphabetically considered. So E is going to come before the M in methyl. So I'm not using the di in considering alphabetical order. So E for ethyl goes first, for ethyl, and then followed by 2,3-dimethyl. And lastly, I'm going to name out the parent chain. Parent chain is 6 carbons long. That is hexane. Now, for those that are wondering, why is the numbering going 4 and then 2, 3? Shouldn't we go in order that leads to starting off with the lowest number and going to the highest number? No. That numbering system is just letting us know on what carbon the substituents lie, but the preference on how to order them in the name is based on the name of the substituents. So I always want to name out those substituents of the same priority in alphabetical order. The way that they're numbered on the carbon chain, wherever they fall is wherever they fall. Final name of this compound, 4-ethyl 2,3-dimethyl hexane.